All right, we have another integral from Caltech Math Meet 2022 Finals number 5. For this one, what I want to do, let's do two methods on it. We'll do the short way and the long way. The reason is because oftentimes when you have the floor function, you have that choice. You could do a U-substitution to clean it up, or you could just leave it and work with it the way it is. The trade-off is when you do the U-substitution, in some ways it's kind of easier to see what's happening. I mean, it kind of depends it kind of depends how you feel about it, but let's do it the long way. So it's going to be solving for x here in our u sub. It's going to be x equals e to the u. Take a derivative, dx is going to be e to the u du. So then we get to do a substitution. We plug in 2e here. When we do that, we get natural log of 2e, but that can be split up. That's the same thing as ln 2 plus ln of e, and ln of e is just 1. So I'll write it like that, just kind of expanding it all the way up. Then natural log of 1, that's just 0. Here, this thing becomes the floor of u. That's nice, that's better, but we have this part here, so we have some extra stuff to do. Then next what I want to do is just clean up these bounds. I want to get it separated on an integer value so that this will simplify. So how we can do it is we can break it up, go from 0 to 1, then we have this right here, and then we'll just do one more integral to get the rest of it. So we'll go from 1 to ln 2 plus 1. Just keeping in mind, ln 2 I think is something like 0.69, and so this whole value would be something like 1.69. That's why we don't have to go all the way to 2, is because it's not part of the bounds. So then here we get the same thing here. But then knowing that like we know here our u values are between 0 and 1, and the floor rounds us down to the next highest integer. So here, if everything's between 0 and 1, this is going to get rounded down to 0. But if that's 0, it's going to zero out this whole integral, so this whole piece just goes away to 0. And then we can do the same kind of thing over here. All of our u values are between 1 and 1.69, so they all get rounded down to this value, the 1. So let's just, if you want to, maybe let's just show it. So that's a 1 right there. But now we can just do the integral of e to the u. That's just going to be e to the u, and we just need to evaluate it from 1 to ln 2 plus 1. Plug in, here we're going to have e to the ln 2 plus 1 minus, here it's just e to the 1. This here we can break up and we can write it like e ln 2, just like exponent properties, doing it like this. Wait, that's not right. We need to subtract that. But e ln 2, that's just going to be a 2. Let me erase it so I can save some space right here. So e ln 2 is the same thing as 2. So we just have 2e minus e. Put that together for my final solution on it. We just get e, and that's it. Okay, so there you go. Longer way. Not that long. It's just a little bit longer. I mean, it's still like 3 minutes or something. And I think the only advantage of it is just that we didn't have to really think about the bounds very hard, I guess. I mean, as long as we knew what ln 2 is, I guess we still had to break it up. So anyway, let's do the short way next. For the short way, what I'll do is we won't do any substitution. We'll just break it up right away. And the value we want is going to be just e here. It's all about when, for like, if we have e to the 1, this is 1. And if we have ln e squared, this is 2. But 2e is less than this, so breaking it up is going to be really easy. So we'll just have the first one like this, and then the next one we're going to go from e to 2e, and just like this. But then we can do the same kind of idea we did before. Everything's going to get rounded down to this lower value. So you can think of this like being ln 1, and then this whole thing is going to be 0. You could kind of do it a little more carefully. You got to think about like what is e here. So if you were to reach e, then it's 1, but everything's going to be less than e. So this first integral goes away and it's just 0. Same thing over here. We can evaluate it and drop to the lower bound. Again, like I said, 2e is going to be less than this value right here. So we don't worry about that. We're rounding down to this. Get rid of the floor, and then this becomes just an e. But ln e, that's just 1. So go ahead and integrate 1. What we get is x evaluated from e to 2e. Plug in, we get 2e minus e. Put that together for my final solution on it. We get just e again. Okay, there you go. Pretty easy integral today from MIT. No. Okay, there you go. Pretty easy integral, Caltech Math Meet 2024. Thanks everyone for watching. Have a good day.